The USGS today. It was strong winds blowing around that 45-year-old ash. Look a bit like it, but it's not an erupting Mount St. Helens. Mount St. Helens is once again commanding the world's attention as geologists have issued a red alert, signaling that the restless volcano could be approaching another major eruption. The mountain, already etched into history after its catastrophic 1980 explosion, has begun displaying a series of alarming signals that suggest the magma system deep beneath its snow-capped summit is pressurizing and preparing to release its pent-up fury. Rising seismic activity, surface deformation, gas emissions, and subtle shifts in the surrounding terrain have painted a picture that is becoming increasingly difficult for scientists to ignore. The phrase red alert is not used lightly. It represents the highest level of warning, one that suggests that eruption is not just possible but imminent. The implications are enormous, not only for the Pacific Northwest, but for global observers who recall the dramatic consequences of past volcanic upheavals. Before we start, smash the like and subscribe buttons for more updates. The mountain has always been a sentinel of both beauty and danger, towering over Washington state with a jagged profile scarred by past blasts. Now it appears to be stirring from its uneasy slumber with deep rumblings that reverberate across the Cascade Range. Seismographs are picking up swarms of earthquakes, many clustered beneath the crater, and their frequency and intensity are growing. These tremors are not mere background noise of tectonic shifts. They are often interpreted as the movement of magma forcing its way upward, cracking rock as it seeks a path to the surface. In combination with ground swelling and increased fumarolic activity within the crater, the evidence suggests that pressure is building in ways reminiscent of the prelude to its infamous eruption for decades ago. For local communities, the red alert has sent ripples of concern through towns and cities that lie in the shadow of Mount St. Helens. The lessons of 1980 remain vivid when entire forests were flattened, rivers choked with debris, and skies darkened by an immense ash cloud that circled the globe. This time, however, awareness is higher and monitoring technology is vastly more advanced. Scientists can watch the mountain with satellite-based deformation mapping, thermal imagery, and real-time gas analysis. Yet, even with these tools, predicting the exact timing and magnitude of an eruption remains one of the most difficult challenges in volcanology. What is clear, however, is that Mount St. Helens is no longer quiet, and those tasked with safeguarding the public are taking no chances. The issuance of a red alert carries weight not only because of the potential destruction, but because of the far-reaching implications of a significant eruption. The Cascades are part of the geologically active Pacific Ring of Fire, where tectonic plates grind and subduct, generating both powerful earthquakes and volcanic systems. An eruption at Mount St. Helens would serve as a potent reminder that these forces are not relics of the past, but active and ongoing processes that shape the land and influence the climate. A large eruption could disrupt regional air traffic, spewing ash high into the atmosphere and potentially affect agriculture by coating fields in fine volcanic particles. While the ash enriches soil in the long term, its immediate effects are suffocating, clogging machinery, contaminating water supplies, and posing respiratory hazards. The current unrest at Mount St. Helens also highlights the delicate balance between humans and nature in this region. Over the past decades, communities have grown, infrastructure has expanded, and tourism has flourished around the mountain. Hiking trails, educational centers, and viewpoints have made it a destination for those seeking to witness both the majesty and the scars of Earth's power. Yet, as the red alert reverberates, these same attractions become zones of potential danger. Emergency planners must now revisit evacuation routes, prepare shelters, and assess the resilience of roads, bridges, and communication networks in the face of possible lahars, ashfall, or pyroclastic flows. For those who live nearby, the looming threat is not abstract. It is a very real reminder that living in the shadow of a volcano demands respect for its unpredictable nature. Beyond the immediate area, the global scientific community is watching with intense interest. Mount St. Helens has long been a case study for understanding volcanic processes. From dome-building eruptions in the 1980s and 2000s to the intricate plumbing system that fuels its activity. Each new episode provides data that enriches our ability to model magma dynamics, forecast hazards, and understand the broader implications of volcanic eruptions on climate systems. If the volcano does erupt, it will not only reshape the local landscape, but also add to a growing body of evidence about how Earth's interior interacts with its surface. The gases released, particularly carbon dioxide and sulfur dioxide, will contribute to atmospheric chemistry and could, in the event of a large blast, influence weather patterns on a short-term basis. The issuance of a red alert also raises profound questions about preparedness and resilience. How ready is the region to face another eruption? The Pacific Northwest is home to millions of people, many of whom commute daily across bridges and highways that trace river valleys originating near volcanic peaks. A major eruption could trigger lahars, fast-moving torrents of mud, rock, and water that follow river channels and devastate anything in their path. Such flows can travel dozens of miles, threatening communities well beyond the immediate vicinity of the mountain. In this context, preparedness is not only about evacuation, but about long-term planning, ensuring that infrastructure is designed with volcanic hazards in mind. The red alert is a test not only of natural forces, but of human foresight and adaptability. At the same time, the psychological weight of the warning cannot be underestimated. For many residents, the sight of Mount St. Helens on the horizon has been both comforting and haunting. A reminder of past catastrophe and present beauty. The knowledge that it may once again unleash its destructive potential stirs anxiety and vigilance. Yet, there is also a sense of awe, a recognition that humans are witnesses to geological processes that operate on scales far larger than our lifetimes. The mountain's restlessness underscores our vulnerability, but also our resilience, our ability to learn, adapt, and endure in the face of natural upheaval. The role of communication becomes crucial during such times. Authorities must balance between urgency and reassurance, ensuring that warnings are heeded without inciting panic. The issuance of a red alert is itself a calculated decision, one that reflects both scientific consensus and the need for public safety. Residents look to scientists and officials not only for information, but for guidance, clarity, and leadership. The way this message is conveyed will influence how communities respond, how quickly they evacuate if needed, and how they prepare themselves mentally for what may come. In the broader context, Mount St. Helens is a symbol of the volatility inherent in Earth's geology. It reminds us that beneath our feet, vast reservoirs of molten rock and immense tectonic forces are constantly at work, shaping landscapes, creating mountains and sometimes tearing them apart in moments of explosive violence. The red alert is not just about one mountain. It is about the ongoing story of Earth's restless crust. It is a narrative of creation and destruction, of cycles that span millennia, and of humanity's attempt to coexist with forces beyond our control. The very act of monitoring Mount St. Helens represents a triumph of human curiosity and science. The instruments that detect minute shifts, the satellites that map subtle bulges, and the teams of volcanologists who trek across treacherous terrain to gather samples are all part of a global effort to decode the language of volcanoes. Each data point, each tremor recorded adds to our understanding. Yet, as the red alert shows, there are limits to our predictive power. Nature retains the upper hand, reminding us that despite advances, we are still learning, still humbled by the mysteries of our planet.